we need to evaluate this integral for the circle mod z equal to 2, right? First of all, when taking the denominator to be equal to 0, what points we are getting? We are getting plus minus 1. Are these points lies inside the circle? This circle is of radius 2. So yes, because the circle is having the radius 2, plus minus 1, both the points lies inside the circle. And because these 2 points lies inside the circle, we can now apply the Cauchy's integral formula for both these points, right? And what function we have to take? We always take the function to be the numerator, provided when denominator when taken equal to 0, the points which we are getting, both the points must lie inside this circle. If suppose I am having the point, let's say 3, and here then we have the bracket z minus 3, right? Now this 3 point does not lie inside this circle. Then we must include this bracket with the numerator for fz, right? So in this example we are only having 2 points, that is z equal to plus minus 1. So fz is only equal to the numerator. We take fz to be equal to 1. So let's start with the solution now. What is the integrand given to us? We have our integrand to be 1 divided by z square minus 1. Let's make the partial fractions for this. So this is z minus 1 into z plus 1. Make the partial fractions. How to make the partial fractions? Just write z minus 1 and z plus 1 separately. If I take this to be equal to 0, hide this from the denominator. I get z equal to 1. Put this value over here. What I get? 2. So we are having here 1 divided by 2. Similarly, when taking this to be equal to 0, hide this from the denominator. Get the point. This is negative 1. Put this value in this fraction. What you will get? Minus 1 by 2. So write a negative sign and here 2. Right? So our integrand will be changed into this. Let's put this value over here. So this is the integration over the circle, and writing the integrand 1 divided by 2 z minus 1 minus 1 divided by 2 z plus 1 dz. Separating this, let's take 1 by 2 outside and separating the integrals. So this is 1 divided by z minus 1 dz minus integral of 1 divided by z plus 1 dz. Now here we have taken our fz to be equal to 1. And for applying the Cauchy's integral formula, we also need the value of f at the point 1 and also f at the point negative 1. Because when taking the denominator equal to 0, we are getting both the points plus minus 1. Right? So we need the values of the function at these 2 points. Because fz is constant, so f of 1 is also 1, f of minus 1 is also 1. Same values. Now since this fz is analytic inside and on the circle mod z equal to 2. Analytic means this is differentiable everywhere except at the points plus minus 1. So writing this, since it is important to write fz is analytic inside and on the circle mod z equal to 2 and the points z equal to plus minus 1 also lies inside the circle. This is the condition to use the Cauchy's integral formula. So now we are going to apply the Cauchy's integral formula for both these points, that is for both these integrals. So this is equal to 1 divided by 2. Okay, applying the Cauchy's integral formula for the first integral, When taking this denominator equal to 0, we are getting z equal to 1. So for z equal to 1, we are applying the Cauchy's integral formula here, and the value is, just write 2 pi iota f1. We are having the single bracket. The bracket is having no power. So we just need to apply the Cauchy's first integral formula for this. Likewise, minus applying the Cauchy's integral formula for z equal to -1. So multiplied with f minus 1. F of minus 1. So this is 1 divided by 2. I am taking 2 pi iota outside common. F1 is 1 and f of minus 1 is also 1. So this is equal to pi iota into 0, and that is equal to 0. So the value of the given integral is 0. So the answer for this integral is 0. Thank you. Alright, have a nice day. Thank you.